Hi, we are presenting on our project, Active Posture Detection and Tracking. I'm Alex and I work with Eric. Nowadays, due to the COVID situation and the prior lockdown situation, people are spending a lot of time indoors, especially in front of their computer. This leads to a rise in the need for ergonomic chairs and especially an ergonomic setup at home. However, most chairs that have IoT embedded in them are for gaming to enhance the experience. However, this isn't what most customers are looking for. My partner and I were originally going to make a smart chair to address these concerns. However, we have a solution that is more compact, more simple, and more affordable, and that is a gadget placed on top of the monitor to track the user's posture. We think that there will be a large market for this because people don't like putting a lot of effort, a lot of time, or a lot of money in trying to be healthy. We have one means of sensing, and that is our ultrasonic sensor to track the user's position from the monitor. And we have two means of actuation based off this data. We have the LEDs to establish whether or not there's a Wi-Fi connection to the gadget, and also to alert the user if they have bad posture. Now, if the user ignores this, then there is another actuation, which is the pop-up window to tell the user that they really need to fix their posture. Here's our hardwire setup, and you can see that we have three LEDs in the left-hand image, and in the middle, there's our simple ultrasonic sensor setup, and on the right-hand side, you can see that this is our overall setup. This is our IoT implementation. We have two peripherals, as mentioned before. The ultrasonic sensor sends the data to the ESP32, which sends that data and its corresponding time data to the Hive MQ browser client, which acts as a broker for the MQTT protocol, which sends that data to the host computer. Now, the host computer can decide what to do with this data. If it decides that the user needs to correct its posture, it can send a pop-up window to alert the user. It can also take all this data and record it in a CSV file for further data analysis.
Let's delve a bit into code structure. We have a main script that we flash onto the microcontroller that controls hardware peripheral actuators, such as our LEDs, takes in sensor data from, for example, our ultrasonic sensor, and sends data over a communication protocol, which we use MQTT at a rate of 10 Hertz. We have a main script on our host computer that takes in the data from the ultrasonic sensor over the MQTT protocol, writes it to a CSV file, and applies a mean filter on this data. Also, if it senses that the user's posture is bad, for example, if the user's distance from the computer screen is below 30 centimeters, it sends a notification to the pop-up script to send a notification onto the screen. And the pop-up script basically handles all the web interfacing in order to send this pop-up to the screen. We have a history feature that after the user terminates the program, sends all the data to a CSV file and has a recording of the user's posture over the whole time at a rate of 10 Hertz. We have a simple MATLAB script that plots this data so that the user is able to qualitatively view their posture habits and see for how long they are below that 30 centimeter threshold. We have a demonstration of our project working after the device is turned on. We activate first our plot script, which, as you can see, receives the data from the ultrasonic sensor. And we also, on the right, enable the script for the pop-up. When my face is too close to the screen, you can see that the computer sends a pop-up onto the screen to alert me of my bad posture. After I terminate both programs, it saves the data into a CSV file, and we can use the MATLAB script in order to plot the data and see the posture over time. Some improvements that we can make to our project is, for example, adding an active harness to physically correct user posture. However, this would require a motor with a higher power density than we have in our MicroLab kit. Also, real-time posture plotting would be better for the user to see their posture changing over time in real time. Integration of the ultrasonic sensor with webcam would allow us to integrate our hardware with pre-existing laptops much easier. And finally, having a network of sensors, other sensors, for example, IMUs, to give a more accurate posture model would be better for estimating the user's posture. For example, if we look at the neck and spine angle, this would give us a better indication if the user's in a worse posture than he was before. Thank you.